Okay, so this is part 2 of this battery problem, chapter 23. And what we're going to do is find a confidence interval for the lifespan of the battery. We already know that the company hasn't met its goals, and it should be less than 300. So our alternative hypotheses, which I should say our null hypotheses, was 300. Okay, and so mu equals 300, and our alternative was mu is greater than 300, and we weren't able to prove this, so we had to retain the fact that the company hasn't met its goals. But the question might be, let's just say you're an executive and you don't want to get fired, so you want to say, well, we didn't meet our goals, but we're really close. So the executive might say, well, how close were we? Okay, so let's do a confidence interval. So let's think about this. Now, if you forget, because we're going to have a lot of different data to work with, always start with it's an estimate plus or minus a margin of error. Okay, so in this case we're working with means, so we're going to use our x bar as our estimate, plus or minus, and now we're going to need a t star value with degrees of freedom, so to specify which model, and then we're going to use the standard error of x bar. Okay, so some of this stuff we already have. Let's go back. Let's see, x was 306, here it is, 306.25, x bar, the mean, sample mean, 306.25 plus or minus t star of d. Actually, we know that the sample size was 10, so this is going to be 11 degrees of freedom. And then our standard error, where did we calculate that? Right here. The standard error is 8.461. So 8.461. Okay, so now let's talk about how do we find t star. It's very similar to finding z, okay, and in fact you could use c. So that's not a very good picture, but that's okay. So this is 90% of the area, 0.90 is right there. So this would be 0.05 and this would be 0.05. Okay, so t star is going to be found by using inverse t. Okay, and I think that's number 4. That's right here. Okay, inverse t. And what we're going to do is we're going to give it the area to the left. So this is really the positive value right here. So, but I cheat. I know it's symmetric. So if I find this t value right here, I know I'm good. All I got to do is take the absolute value. Okay, absolute value. So I'm going to put in 0.05, but the difference is now I need to put in the degrees of freedom, which is 11. Okay, and I'm going to take the absolute value of that. So put that into my calculator. What I get is 1.796. Okay. Now, if you can't find it this way, you could use the textbook, and go to the t table. Okay, find df equals, first it's going to be 1 t table 1 tail test. So so df would be 11. So go down and find df on the table. You're going to have some numbers, and df would be the first one right here. So go down and find 11, And then up here we call these alpha values. So your alpha is going to be 0.05. So it's going to be somewhere in here. So 0.05. You see 0.05, just go down and then you'll find the value. Okay, so just make sure you can do that. Okay, so now we have 306.25 plus or minus 1.796 times 8.461. So if you do that, our confidence interval becomes, so we get 25.25. So we're going to multiply this and subtract. I'm assuming you know how to do that. We're going to get 291.05 to 321.45. Okay? So it contains 300. So we can't say it's above 300, but what you might argue to the executive in order to save your job is to say, hey, you know, we're kind of in the middle. Right? If you look at this, we're right on 300. So I'm assuming next year we will meet our goals. Okay? So in any event, you have to come clean at some point and say, I am 90% confident that you don't have to really say it true, but you can if you want, that the mean battery lifespan is between 291.05 to, or and might be a little bit better, and 3 to 1.45 minutes. Remember, with means, you're probably going to have to use units. Okay, so that's how you do a confidence interval. So I'm going to stop it there, and then I'm going to do the last part as a separate video.